Have you ever been to Starbucks? It's just a fancy, overpriced coffee place where hipsters go to get their coffee. And believe it or not, you can order any type of coffee there. You just have to blurt out some words and the barista will make that happen. Anyway, our goal is to build a software for a coffee shop similar to Starbucks that will handle orders and calculate the cost of the coffee. So this is a quick overview of how coffees are made. A coffee is made up of a beverage and condiments which are added on top of the base beverage. A beverage can be an espresso, dark roast, house blend, decaf, etc. And condiments can be milk, mocha, syrup, whipped cream, and stuff like that. Now, for example, if you order double mocha, triple steamed milk espresso, to get the final price of this coffee, you just need to add the cost of the beverage and all the condiments that went into it. Let's take a look at the class diagram. It starts with a component which needs to be decorated, but this will be an abstract class because we will create concrete components from this abstract class. So there will be a concrete component. For our coffee situation, the component will be beverage, and the concrete components will be the types of beverages that we offer. For example, house blend, dark roast, espresso, etc. Next, we have the decorator class, which will extend the component abstract class. And this decorator will also be an abstract class because we'll be creating concrete decorators from it. For our coffee, this will be the condiment decorator. And lastly, we have the concrete decorators. These concrete decorators will have an instance of the component that we are trying to decorate. So for example, for our coffee, the concrete decorator milk will contain an instance of the beverage B, which we are trying to decorate. We will understand this in detail while explaining the code. But you can see here, the concrete decorators have an instance of the beverage. Now let's try to implement and see how it actually works. So here we have the beverage abstract class, which contains a description, a string description. Initially it is unknown beverage because this is an abstract class, and an abstract method cost, which will return the cost of the beverage, and a public method of getDescription to get this description value. Now the concrete beverages, let's take a look at those. For example, dark roast, it overrides the description value to the value that it wants to override. And it also implements the cost method, which will return the cost of this beverage, which is dark roast. So this dark roast has a cost of $2.5. Similarly, there are other beverages like espresso, which are implemented in the same way. We change the description and return the cost of it in the cost function. Now this is the condiment decorator, which extends the beverage class also, and it has an abstract getDescription method. Let's take a look at concrete condiment decorators now. For example, mocha. Now mocha extends this condiment decorator. It has an instance of the beverage. Now in the constructor of this beverage instance gets initialized, and in the getDescription, it adds its own name along with the description of the beverage instance. Why are we doing this? Because this will append the condiment name to the existing beverage name. We'll see more into this while running this actual code, and we'll see how the chaining works in this decorator pattern. And lastly, we have the cost method, which adds the cost of this condiment along with the existing beverage cost. Similarly, other condiments like steamed milk has its own cost and description. And yep, similarly whipped cream also. Let's take a look at how to actually make a coffee from this code. So this is my main function to run this code. I'm trying to make the same coffee, triple steamed milk, double mocha, espresso. So I start with the espresso beverage with my coffee as the variable name. Now to add steamed milk to this, I'll pass this my coffee instance to the steamed milk constructor. So when I create this new steamed milk object with this instance passed here, espresso instance, so this, when it is passed here, it is just plain espresso. This plain espresso is stored in steamed milk member, right? Data member here, because it is, I'm passing it as the parameter to the constructor. It will store that plain espresso here, but whenever I want to get the cost of it, it will return after adding its own value, like its own cost with the espresso cost. So this is how like the chaining works here. We can see it again when I add another steamed milk. Now this steamed milk is passed an instance of this my coffee. So this is changed now. This constructor returned an instance of beverage which contains espresso and steamed milk, right? Now this is passed to the next steamed milk. So there will be like two steamed milk chained together. And similarly, another one. Next we add mocha to the coffee. It will add its own cost and description. And another one. Now if I run this, it will show me some description and cost of the entire coffee. Let's try to run. So yeah, it says espresso, steamed milk, steamed milk, mocha, mocha. And the cost is $5.24. So yeah, this is how it works. Let's take a look at this diagram to understand how the actual chaining works. Initially, we created an espresso object, the cost of which was $1.99. Next, we wrapped this espresso object with a steamed milk object. We were able to do this because they both share the same base class, which was an abstract beverage, right? When this object is wrapped, the cost function of the wrapper calls the cost function of the inner object. This is how the cost is added of each condiment and the beverage. Similarly, again we wrap this object with another steamed milk, and then with one more, and then double mocha, and then when we call the cost function of the outermost object using a chain, it will call all the cost functions and add all of the values and return the final value to us. Similarly, you can visualize the description function as well. When we call the description at the outermost level, it will add all of the description of all the condiments and beverage and return the whole description to us at the end. So if you encounter decorator pattern anywhere, you can just visualize this kind of diagram. Like there is an inner object and then there are wrapper objects which wrap and add some functionality to the inner one, and you will be good to go. Let's recap the decorator pattern, what we discussed in this video. So this pattern provides a flexible alternative to subclassing for extending functionality. Next, given that the decorator has the same supertype, which is the abstract class, as the object it decorates, we can pass around a decorated object in place of the original wrapped object. Decorators have the same supertype as the objects they decorate. And lastly, the decorator adds its own behavior either before and or after delegating to the object it decorates to do the rest of the job. So this was all about the decorator pattern. All the code and theory you'll find in the description, and I'll see you in a bit.